Hi, my name is Vinay Wagh. I'm a director of product here at Databricks. I've been with the company for nearly almost 3 years now. My focus in the company is around all things platform infrastructure and security. And today I have with me Aaron Davidson, who is one of the senior staff engineers at Databricks, leading what we have termed as Project Nephos. Project Nephos is a project within Databricks that's building a new version of our compute platform. And today I'm really excited to talk to you about not only the genesis of what brought us here, but also what the immediate and the future looks like. So let's get started. If the last decade has shown us anything, it's that companies that are able to amass large amounts of data, be able to analyze it, are able to build new products, customer experiences, and business efficiencies that have allowed them to dominate their market segment. We believe that the companies that are going to dominate the next 10 years in every market segment are going to be under the hood data companies. These are going to be companies that are building data products. So what are data products? Well, a credit card is a data product because it relies on collecting and analyzing thousands and thousands of credit card transactions to possibly even detect fraud. Companies that do this well are able to get better credit card rates and save a lot more money on fraud. Pharmaceutical drugs is a data product because it relies on collecting a lot of patient health data as well as drug simulations in order to build new and release new drugs sooner to the market. In fact, self-driving cars are a data product because they rely on collecting large amounts of map data along with a lot of sensor and image data to essentially steer you. So the question is, well, if data is so important to your business, then are companies doing it? Well, we have some data about the data. And what a recent McKinsey Analytics report says that they've analyzed a bunch of companies that are in different stages of building out their data architectures, from early stage to have invested in modern data architectures to full-fledged trying to operate modern data architectures at scale. And what that study found was that high-performing companies, the ones who are performing at the top, are likely to have the more modern data architectures that support analytics at scale. That means the scale word actually here is pretty important because that's when you end up deriving the benefit of the investments in data. These companies who are performing well have realized that innovation happens when you enable all of your users with all of the data they need in order to build products, efficiencies, and new customer experiences. Right? It's not about a single team within your company. It is about having all your machine learning engineers, scientists, and analysts be able to query data that they need in order to build do their work. But bridging this gap between all of the users in your company with all of the data they need has been a challenge, and in fact still is. If a recent MicroStrategy report shows us that when employees of these companies were asked about, how do you go about making a data-driven decision today? 79% of these employees said that in order to make a data-driven decision, they actually have to reach out to IT, maybe even a business analyst within their company for help. Only 7% of the companies that actually, 7% of the employees, would have access to a self-service tool where they could help themselves. And the rest were actually winging it, right? And so what is the reason for that, and how do you go from being that company to being one of the high performing ones? And we believe the lakehouse architecture is the answer, right? It allows you to bring together data lakes and data warehouses under one umbrella, allowing you to process and analyze large amounts of structured, semi-structured, and unstructured data within the same interface, be able to do machine learning, analytics, and AI, all in the same sort of under the same data umbrella. And Databricks and our data analytics platform provides that, right? It bridges that gap. It sits between all your users and all the data. Now, that being said, going from a small team that's building a little project, let's say a recommendation engine, to full-fledged operationalizing everybody in your company to be able to use data are two different challenges, right? And when you go from a small team to all your users, you're going to see a lot of different patterns, like the amount of compute infrastructure you use, the number of environments you have to operate. All of those things increase the complexity, and that's just the challenge that comes with scale. The challenge is, if you think about it from the perspective of what the users need in order to get access to this and actually run their queries, the challenge comes in sort of three areas when we look at a platform, right? And the first one is elastic instant compute, which is most of these users need access to be able to run these queries. They don't want to wait. Giving everybody, let's say you have thousands of engineers that you want to enable, giving them access to instant compute is a challenging problem, because now everybody needs to be able to get compute when they want it. The other aspect of it, this is security and compliance as well. Well, we keep talking about all users, all data. Well, that can sound scary to people within the infosec and governance team, because you want to protect that data is also really valuable and probably has a lot of confidential stuff in it. So you want to make sure that you account for a security and compliance built into the platform before you enable all these users. And the third is performance and cost, right? You could go ahead and let every one of your employees do whatever they wanted with with any tool, but then it's going to come at a cost, and it's also going to be inefficient. And so when you look at this challenge holistically, you look at it as enabling all these users to be able to do what they want. You have to tackle these three problems, and you have to figure out how you're going to operate in that environment. So let's take each of these one by one, right? Let's talk about elastic instant compute. We've been talking to customers for a while now, and when you take into account that to launch an instance in the cloud providers, and this can be conservative or optimistic depending on which cloud provider you're talking about, it takes minutes to launch an instance. Let's just say that, right? Maybe it's 3, 5, in some cases it can take up to 10, depending on what type of instance you're trying to launch and how many of them. And so it takes that long to launch it. And if you look at engineers who want to use that data, right, they don't want to wait for these clusters to boot up, because it's how they work, right? I mean, imagine if somebody told you wanted to use Google Docs, and I said, hey, to start editing this document, you got to wait 5 minutes to, for the compute to boot up. It sounds ridiculous, but that's kind of what these developers are doing. They sit at their desk and start typing code. So they don't want to wait. The other data point here that's worth considering is that most of the jobs, if you look at 80% of the jobs that they run for about 5 minutes or less, right? And if you contrast that with the amount of time it takes to start an instance, you're going to wait 5 minutes to run something for 5 minutes. It just seems it's like a long time, basically. And the third is that in a lot of cases, in a lot of our conversations, data teams have been tasked with providing an SLA to their end users. So let's say, for example, you create your goal tables, and they're meant for querying business data by analysts who produce reports or whatnot. In a lot of cases, data teams have to guarantee that, hey, your query is going to be able to run under 1 minute. And that is challenging in this environment, because if you decide that you want to launch a cluster when somebody wants to run a query, of course, that's going to take a long time. You've already violated your SLA. But even if you decide that you wanted to auto scale when somebody ran a command and you said, you know what, I want to keep a cluster running, I'll just auto scale, and so I don't have to launch all instances when a query is run. Even that doesn't work, because auto scaling also is launching instances. And let's say it has to wait 5 minutes or 3 minutes to launch another instance. It is going to slow down the query, and it is not going to probably meet the SLA. Right. And so these problems if you look at all these problems combined, instant compute becomes getting instant compute is something that requires investment and is also challenging. It is challenging if you don't have to run compute all the time, because some of the customers that we talked to who encountered these problems were able to get around these problems by just not shutting off their clusters. They said, we'll just keep these things running, and that's it. So you don't have to worry about it. But then you're provisioning for essentially worst case all the time, at least for every, kind of working hours, maybe, so that becomes inefficient. Now let's look at the second problem, which is compliance, security and compliance. And in this scenario, I think it's important to realize that the way teams are structured today in these large companies, each team is given their own cloud environment. So let's say hypothetically we talk about AWS, I get my own VPC, AWS account, my billing happens based on what I use in that account. And so each team like has to launch infrastructure in order to process, which means for data analytics, if you're an AI and other sort of applications, if you're launching these VMs that are going to process the data, they're running in your environment in your account. Now, what are the challenges with that? Well, if you look at it, once you have an environment, you have to but rather you have to configure the firewall rules for making sure that, the internet isn't open to it. You have to prevent data exfiltration. So, making sure that you're only allowing access to the things within your environment that these clusters are allowed to access. And so that requires a bit of sort of configuration and operationalization. The other thing is compliance and monitoring, right? There are VMs running there. There's an environment in which you're running compute that possibly, processes sensitive data. At some point, you're going to have to, many of these companies we talk to are also regulated. So at some point, they have to kind of provide audits, what's going on, detect for any kind of malicious activity in this environment. That requires investments, right? Because now you're investing in tools, you're investing in agents, you're investing in products that are going to help you kind of analyze this, and agreed that they're probably centralized in a company, but every environment that you spin up adds to it, right? It adds to the cost and it adds to the operations. The other part of it is just the infrastructure operations associated with it. Well, and having a VNet or a VPC or project or whatever is fine, but then being able to configure it correctly, making sure that you're managing drift, making sure that you've automated all the infrastructure deployments either through CloudFormation, Terraform, whatever you might be using. All of that is something you have to do in order to start kind of being able to launch clusters and you use your data and stuff like that. So those are the challenges. Now you take that sort of approach and then decide that you want to scale it across the company, right? Across all your teams. And in many cases, they are probably hundreds, if not, in some cases, we see in the high order of hundreds, different AWS accounts and teams that have to, get access to data. This means that you're now, you have to now, start managing all of that infrastructure, environment monitoring, firewall exfiltration, all of these kind of things. And so, it's just something that is something you have to master before you can scale it towards that goal of having all users get access to the data they need. And so, it requires scaling and operations in order to do that. Now let's look at performance and cost management as a vector. So if we take that environment where a single team is operating, let's just zoom in on one thing. So let's say you take a team that's building a recommendation engine or some project that they've decided to do. They have a pattern of launching clusters, right? There's a team that comes in every day at 9 a.m., possibly, leaves at 7 p.m., whatever the timing is. They launch a few clusters. They're using some number of machines. Their usage goes down towards the, night, and then they come back next morning, or they have jobs running that run periodically, maybe daily, hourly, weekly, whatever it is. They have these clusters and infrastructure needs, and they're, that's kind of their level of activity. Now, as somebody who's managing the platform or a leader in a data team has to basically be able to track usage in order to report, hey, you're using so many VMs or you're spending this kind of money, and that's kind of reporting that has to be built in to monitor what's going on. And then you have to monitor the utilization. What if people are running these machines? If I launch a 100-node cluster and I barely even use it, how would you even know about it, right? And so people, or sort of data teams, in order to kind of be efficient, have to build in some kind of monitoring and utilization if they want to be able to save costs, right? There are, we've spoken to a lot of customers where they're like, well, this is, data is a priority. We're not looking at that right now. Our focus is on enabling people. Well, yes, fine. When you go to a certain scale, you might care about it. And so building in this utilization and monitoring is key to be able to optimize on cost. And then, based on what you're seeing, based on the data you have to configure the right cluster policies and spot instance policies and things like that, so that you can over time, you can mitigate on the cost, right? Because one thing that in this environment that you have to understand is that when these teams build their products, they themselves do not know exactly what their compute needs are going to be, right? If you write some Python code and I ask you how many cores do you want, like in all likelihood, you're not going to know what that is, because you cannot map, code to number of cores. And so you start with not knowing how much compute you need, and you have to converge on the right amount. And that's, that requires tooling, and like it requires you to care enough that you build all this tooling in to do it, right? And so it's something that you have to do. And then when you decide to scale it across all your teams, I imagine all these AWS accounts or all these, Azure accounts or whatever, all of them are running these VMs. You have to build in this tooling and then kind of also be able to optimize, right? Not just get visibility, but tell these teams, hey, maybe you should use a different instance type, or maybe, consolidate your clusters, you're spending too much money. Those kind of things, all of this is tooling that has to be built. So if you look at it from this perspective, these challenges is what brought us to Project Nephos. And Project Nephos is a new version of that platform that we've started work on, that we will have an early version of this platform this year, is aiming to address these issues, right? It's basically building a compute platform that is going to come with that is going to be built in with certain sort of flexibilities and built in with certain optimizations, such that you don't have to worry about it. Let's talk about it at a really high level first before we dig in, right? So the architecture for Project Nephos is essentially what we're going to do. The change from what we've been doing is that we're going to now run the cluster compute in our environment, in our account, and manage it on behalf of our customers. Aaron is going to go into the architecture of how we isolate these things and go deeper into how we kind of run these things. But at a high level, we're going to have workspaces within Databricks. No matter how many you spin up, they're going to have clusters that we are going to take care of running and isolating for you. And what we would do is make sure that we are responsible for the compliance and security and audit of this environment, making sure that you don't have to worry about these tools and monitoring and auditing and all the stuff that will be built in. We're going to also take care of being able to sort of in a way help you optimize cost for these VMs running, and also the performance cost optimization trade-offs, as well as be able to give you instant compute. And let me go I'll go a little deeper into that. But the idea is, in order for us to operate, allow you to scale, we need to be able to control this and almost manage it programmatically as opposed to manually. And that's what it takes to do it, because it's not something you can do, manually. All right, so let's take a look at how we achieve instant compute in Nephos. All right, so let's take, for instance, we have a whole bunch of users that have created workspaces and they're working in their own environment, and they're running queries and jobs, and and that requires the launching of clusters, and those clusters are getting launched now within our environment, or a VPC that's managed by Databricks in a Databricks cloud account. And as these VMs are launched, they get a cross-account identity that allows them to access the data in your environment in order to process and analyze the data, right? This is something you would have provided when you created the workspace, which is something you do today. You would have to add the ability for us to assume a role in order to access that data. But once that happens and these clusters run and they're processing queries, we start learning about how many VMs are getting used, right? Across different workspaces or even across an entire region. And then we use what we're learning to predict at any given point in time what the need will be at any given hour in the day, right? In any given 10-minute window, how many VMs are we going to need? And then we use that to kind of pre-launch VMs and keep them ready in a pool. And those VMs are just sitting there waiting to be assigned to a cluster. And as these users launch more clusters or terminate them, we basically allocate in free instances from this pool. Now, we don't free instances back to the pool. We always give instances back to the service provider, cloud provider, whenever we're done with them. But there is a set of pre-launched VMs just sitting there so that when you do new cluster launches, you get it right away, right? So this is what allows us to give clusters in seconds as opposed to minutes, which is a game changer. And I'll explain why and the implications of this that may not be obvious. Now, once we have a system where we are in control of kind of launching, isolating these things and monitoring them, we have, you know, a set of things that we can do here, right? In the near term, we can scale the clusters based on usage, right? So we can figure out, okay, you know what, this cluster has more users or more queries being run, or to scale it more aggressively or less aggressively. Basically, we can be more flexible about that than we are today. And then we can manage the spot fleets and policies on behalf of the customers. So one thing we can do is kind of make sure that if reducing cost is something that's a priority, or like managing cost, then we can kind of make sure that, you know, all the worker nodes for these VMs, for these clusters, are purely based on spot. What should be the percentage of spot, in order to make sure that you never are slowing down the workload substantially, but at the same time you're saving money by making sure there's the right percentage of spots to make it cost effective. So those kind of things, as well as policies that govern, like our existing cluster policies, those kind of things we can configure on your behalf. Then we can also auto terminate frequently to save cost. This would not be possible if we weren't be able to build a system like this, because if today our customers do not auto terminate frequently enough, and the reason they don't auto terminate is because of the first reason: users do not like to wait for machines. And so imagine if I auto terminated, every 30 minutes, right? And because of inactivity. If any of these engineers or scientists went into a meeting and came back, their clusters wouldn't be up. They'd have to relaunch them. So what we've kind of figured out from our conversations is that 90 minutes seems to be an acceptable one for non-critical clusters, so that it accounts for somebody going to a meeting, taking a short break, and coming back to their desk. Allows them to kind of continue running without having to relaunch clusters, right? But with this architecture, you can just terminate them whenever you want, right? Like you can say, I want a 10-minute auto terminate, because when it launches up, well, you're getting it in seconds, right? So it's not like you have to wait a long time. So this changes it, because now if you auto terminate frequently, you're saving money. And then in the future, we're going to focus on, automatically adjusting the instance and cluster sizes. It's something, is aspirational, where we can, if you're using a small cluster, we can say, you know what, you don't, if you're using, a large cluster, we can recommend and say, you know what, you don't really need a large for this, because it's not really being fully used. Maybe you should use something smaller. Those kind of things are possible, as well as we can, look at a future where we could schedule jobs in order to reduce cost, right? And then you can optimally schedule them. And a simple example of this would be like, if we took a 10-node cluster and decided that we are going to run, these 5 jobs on it, and that'll increase the utilization of this thing, but not compromise on the security aspect, since they belong to the same customer, same team, or whatever. We can actually reduce costs and increase the efficiency by doing that, right? All it takes is a little flexibility on when that job completes. And so as long as that exists, we can make that decision and say, you know what, batch these together, run them at the same time. We've now saved time and money. And so those are the kind of things we can do with this platform. So in essence, it's not just about security, which we spoke about, instance compute, as well as performance and cost savings. Nephos is about simplifying. And to talk more about how we simplify our product and go deeper into what sort of our network and isolation and other things look like, I'm going to hand it off to Aaron. Aaron, you want to take it?
Thanks, Vinay. As Vinay said, Nephos is about simplifying the Databricks product and compute management. So let me talk about how. So first, we want to talk about simplifying the notebook experience. So if you use Databricks, you'll know that before you can get started with a notebook, you need to provision a cluster. And that can actually be somewhat of an ordeal by itself, because you need to decide a whole host of configuration options. For example, instance type, the number of nodes, the Spark version, whether you want spot or on demand. And oftentimes a different team will actually own the cluster configuration and the management of clusters. And so you might have to talk to that team just to get started. So one way that Nephos can help simplify this, as we move the compute into the Databricks account, into our management, we can actually make it super easy for users to get started and just run a command on a notebook. and by default, launch a small cluster for them, for that individual user, for that individual notebook session. And if you want to then later attach to more data, or you want to have a finely tuned cluster, you can still attach to that existing cluster. But in general, the goal is to make the default experience really simple, really streamlined. And we can do that using nephews. Another example that Vinay also mentioned is around simplifying our SQL Analytics product. So this is Databricks SQL is a first-class product in Databricks where people go to create dashboards or ask questions, ask queries, and generate reports, that kind of stuff. But today in SQL, although SQL is a very interactive thing where people come, they'll do a session, they'll ask a few questions or generate their report, and then they'll go away having done that job and maybe come back several minutes later, maybe hours later, a whole day later. Today, it's very difficult to manage the lifespan of these clusters, because if you want to save cost, you'd like to turn off those clusters immediately. But then when you come back, you may have to wait several minutes for those clusters to be respawned, because we actually give the VMs back to the cloud provider because it's running in the customer account, in your account. When you want to terminate a cluster, you actually have to hand those VMs back, or else you're paying for them. And so then to recreate that cluster, you have to relaunch those VMs from the cloud provider and reprovision Spark and connect it. And that's what takes time. That's what takes a few minutes. On the other hand, if you want to provide a good user experience, then what you're going to have to do is either keep a cluster running all the time, or provision a warm pool, which would let you share those VMs across whatever cluster needs them. But in either case, you're actually paying for those VMs even when no one's using them. And so you have to make this trade-off. Either you have a worse customer experience or you pay more money. And so as we move the compute into our account, we can actually take this trade-off away from the user by virtue of giving you both instant compute. So once you're going from no compute to running, we can do that within seconds, but also no cost overhead without having to pay for them while you're not using them. And the way we can do that is by having a pool of shared VMs, of warm VMs in our account, and amortizing that across all customers. And so it really transforms the way users use and manage the SQL experience, that they can come and go as they please without paying for the VMs all the time. It really fundamentally shifts the paradigm. So that's really exciting. But as we move compute into our account, we can actually kind of break out of the bubble of hosting Spark as kind of our main way to access large amounts of data and to build data products. Today, Databricks launches Spark clusters in the user's account. And Spark is great for batch processing, for stream processing, and for SQL, all sorts of things. But it's not good for many data use cases, such as model serving. It's very hard to build a model serving system on top of Spark. And so by moving compute into our account, we can abstract away the kinds of compute that underlie Databricks, and we can actually build new types of products. One example here is model serving. For those not familiar with model serving, the idea is you train a model, let's say it's a recommendation model, a Netflix recommendation model, that takes a set of features about a particular user and produces a set of recommended shows in this case. So many times you'll apply this model in a batch fashion, in an offline fashion. Let's say take all of yesterday's users, predict the shows they want to watch, and then use that for tomorrow. Or you could do streaming, maybe every hour you incrementally update it. But many use cases are subject to wanting real-time inference, meaning that as users actually make queries on the website, they need to hit the model and get the recommendations out. And so this is where at Databricks and in general, there's a gap in actually being able to operationalize and productionize machine learning models. In particular, it often requires an extra team in the middle. So a data scientist will produce a model, it'll be great, and then they have to hand it off to another team to rebuild that model and operationalize it. And at Databricks, we'd like to remove that step to allow the data scientists to directly productionize it, directly do the A/B testing without the need for that intermediate team. And so we can do this using nephews. Because we can abstract away the compute, we can start running model serving as well as Spark clusters in our account. And we can manage the availability and scalability of that offering. So overall, nephews is about simplifying data science and machine learning. The first hard part of any data science and machine learning platform is actually scalability, availability, and security. And these are very hard things to build. But at Databricks, this has become core to our product. We've gotten really good, and we're always improving at scalability, availability, and security. And so one awesome thing about Nephos is it gives us the ability to apply this expertise to do new domains, such as model serving. But there's many other data products out there that Databricks can help build and will build on top of the Nephos architecture. The model serving is just the first that we'll go to market. And it also provides fundamentally faster compute spin up. So we can keep these warm pools amortized across multiple customers, and that really helps both the notebook and the SQL products. So the first use case that you'll see production ready to use is that SQL product. So later this year, you'll be able to get instant compute. So cluster startup time less than 15 seconds is our first goal. We can always reduce that over time, but we think that's close enough to interactive. We want to be able to automatically tune the price performance by shutting off that cluster after 10 minutes after the last query finished. And we want to keep it simple and secure without any operational overhead. We'll manage the compliance. We'll keep the simplified access controls. So we'll propagate user identity, federate user identity through our clusters, back to the cloud storage, back to the catalog layers. That's very important. And we'll have our standard features of SSD encryption, DBFS, instance profiles, and of course, strong isolation between customers. So this is the first one that will go to market. Now, I've talked about some of the use cases of Nephos and what's coming soon. I want to actually spend some time digging into the architecture as well, and so that you can understand how we build this product and also how it provides that security that's very critical for every use case that runs on top of it. And so let me break down this diagram for you, which explains the architecture. So on the left-hand side, you see the control plane. This is the Databricks control plane services, such as our web applications, such as our jobs engine, such as our cluster manager. This is the same among every architecture. So whether the data plane is running in the customer account or whether it's running in the Databricks account, all that control plane looks the same. So instead we focus on the data plane or the compute layer. This is where the clusters run. This is where the compute runs. So first we have the system services in the top left. Those are just isolated pods that manage the rest of the data plane. Below that are the unallocated, unassigned clusters. And this is very interesting. What this means is an entire Spark cluster ready to go that's already provisioned and it's just not assigned to a customer. So we mentioned wanting to get startup time below 15 seconds. Well, as you may know, Spark is actually a pretty heavyweight process. It's JVM based, so you have the cold start compilation times. It has a Hive metastore to connect to, has to connect to the executors and establish all those connections. So even starting Spark in 15 seconds is hard, let alone any other rejiggering you have to do in the system. So what we decided to do was actually pre-provision Spark clusters, having them ready to go and allocated, and only assign them to customers as needed. And so once a customer does need that Spark cluster, we just plop it over and put it into that customer's domain. And from here, we have two layers of security isolation. The first is the container boundary. So all compute is containerized using unprivileged containers, using AppArmor, seccomp, and every mechanism of detection that we have available to us. So it's a relatively secure boundary, but we don't want to only rely on the container boundary for security because this is running customer untrusted code. And so the second boundary is the VM boundary. And so one key point here is that VMs are not reused between customers. So once a VM is assigned to a customer, either a driver, worker, VM, once that customer no longer is using it, we actually give it back to the cloud provider. We terminate the VM and recycle it through the cloud provider. And we'll allocate a new VM from the cloud provider, but essentially it's all going through that hypervisor layer. So you never have one VM that was used by one customer and that same VM is used by another customer. So that's VM isolation. In addition, you can see these red boxes are the network isolation. And so a VM running for customer A can only communicate with other VMs also running for customer A and cannot establish connections to a VM in the unallocated pool or a VM in the cluster B pool, customer B pool. Okay, so as a result, even if I could break out of the container, VMs are completely isolated from one another, providing strong isolation between our customers. You might notice, so now you might be understand how we do our isolation story, how we do our compute management, but actually equally important is how we do data access. Databricks is often used to access data where it's at. This makes it distinct from some other products such as data warehousing solutions, where you ingest relatively clean data into the data warehouse and it kind of manages it from there. But Databricks is actually often used to do that initial ingestion. And so wherever your data is at, whether it's in blob storage, a database within a VPC, an on-prem HDFS cluster, a Redshift cluster, wherever, Databricks and Spark are excellent at scooping up that data and joining it together and producing those intermediate tables to be ingested into your data warehouse. And so this makes it a harder problem to access it. It often requires IAM controls or network connectivity to those resources. And when Databricks is running in the customer's account, when the data plane is running in the customer account, they can peer it together. They can establish a peering connection. They can give it an IAM role, and they can make the connection happen to whatever private resource you need. But as we move that to our account, these problems become harder. IAM is actually similar because the data plane will be able to assume customer provided roles. Now we have to be very careful that on a particular VM, a VM for customer X, only has credentials associated with the role for customer X. So we still have to maintain that VM isolation, but otherwise we can do the same kind of role-based access. The networking controls, though, are where it gets a little harder, but it's still possible. So let me break this down. In order to do private routing, and so most routing will go to S3, to blob storage, Azure Blob Storage, or Google Blob Storage, and doesn't require this kind of control. But when you need to access important private data, and you need to do it through, to ETL it in, it will still be possible in the Nephews architecture. And so that's what I'm showing here. And it does depend on the cloud providers and the mechanism. So in this case, I'm giving an example of the AWS private routing mechanism. So customer X has a database, an RDS, running in their private VPC. Today, as I said, if you're running a data plane in your account, you could just peer that with a Databricks VPC and then establish a direct connection. But it doesn't work when the data plane in our account is multi-tenant, because then you couldn't have two different customers with overlapping CIDR ranges, and we don't control the customer CIDR ranges. Today, customers can manage this. It's actually pretty challenging when you're running a large enterprise to make all the CIDRs work out so that you can peer everything together. It needs to be peered, but customers can and do this today. So to get a picture of how this works, we have the customer VPC, and in the bottom, we have the Databricks data plane VPC. And there, you can see it's kind of small. You can see that there's customer X VMs and customer Y VMs running in the same VPC. And that's kind of what makes this challenging. Now, the first step is to create what's called a VPC endpoint service in the customer X VPC. And a VPC endpoint service will allow us to expose this RDS into the Databricks VPC. To back a VPC endpoint, for those not familiar, you have to create a network load balancer, so a layer 4 ELB. And to back that, you have to have a set of EC2 instances. So ultimately, what we have to do is we have to create some EC2 instances, which are proxying over to the RDS, NLB proxies over to those EC2 instances, and the VPC endpoint service will be associated with the NLB. That's relatively complicated. Hopefully, Amazon will make it easier in the future to just say, I want to expose this RDS directly as a VPC endpoint service. But today, we need this extra layer of indirection. So as I said, this is only for very important data that you need to access from the data plane, and may require an AT team today. But hopefully, this will become easier in the future as Amazon expands their capabilities of their VPC endpoint services. But today, that's what the customer does. They set up the VPC endpoint service, and we take it from there. And so what we'll do is we introduce a new VPC. You'll see why. We have this idea of a router VPC. We bind that VPC endpoint service into the router VPC. And what that means is in the Databricks router VPC, there is now a set of private IPs, private interfaces, that if you access those private IPs, it will actually route to the NLB. It will actually route to the HA proxy. It will ultimately route to the RDS itself. And those private IPs are in the router VPC CIDR range, meaning that it doesn't matter what CIDR range the customer has chosen. Now that we have the VPC endpoint in this router VPC, we can peer the router to the data plane VPC. And now the data plane running in our account on customer X VMs can access the VPC endpoint through the peering. The VPC endpoint will be able to access the RDS through the VPC endpoint service until we have the end-to-end connectivity. Now, equally important, just to point this out, equally important from connectivity is not allowing connectivity from the customer Y VMs. And so the way we do that, you can see these other boxes, these security groups. The customer X VPC endpoint has a security group associated with it. All customer X VMs have a security group associated with it. And it's white, and there's a whitelist going so that only customer X VMs are allowed to establish connections to the VPC endpoint for customer X. And so customer Y VMs are unable to establish that connection, unable to use that endpoint. So therefore, we have secure routing into private networks, allowing you to ETL in that data as necessary. And you can see here that this expands horizontally from multiple customers, and it also expands horizontally from multiple data planes, enabling us to move customers around as they grow across multiple VPCs, so we're not constrained to a single VPC. So that's why we have that router as a layer of indirection across multiple data plane VPCs. Okay, so this showcases how Databricks in the Nephos architecture can both do IAM controls, but also network connectivity where it's important. Of course, that setup on your side is not trivial today, but hopefully, again, it will be easier in the future. All right, to summarize with the roadmap, in 2021, expect to see the SQL Analytics use case on Nephos, both in Azure and AWS. Value is instant compute. In 2022, and maybe somewhat beyond, expect to see not only SQL Analytics, but also the workspace. So that's the notebooks, jobs, arbitrary computation running in our account, as well as that model serving product I talked about, and other products down the line. But these are the three that are already underway. And if you're interested in a private preview, please talk to your Databricks representative, and we'll talk about getting that started. Thank you.